All right, introductory algebra homework 11 starts off using the distributive property, whole number coefficients. So we're going to have a nice whole number either in front or behind. And the distributive property is basically a multiplication. When you can't combine the terms inside the parentheses, you have to use the distributive property to remove them. So basically what I'm doing is taking the 4 times the 6, 4 times 6 is 24, and then I'm taking the 4 times the y. Well, 4 times y we write as 4y, and we have to put the plus sign in between them to separate those two terms. These are not going to be like terms. I can't add a 24 with a 4y, so my answer is just going to be 24 plus 4y. On the second one, it's the same thing. They just put the 6 behind the parentheses instead of in front of the parentheses. But I'm going to take the u times that 6, which we're going to write as 6u, and then I'm going to take the negative 6 times the 6. Negative times a positive is a negative, so minus 36. So 6u minus 36 is going to be my answer because I can't combine any of those terms. So number 3, if I'm going to use the distributive property to remove the parentheses there, I'm starting out, I'm going to do 4 times x. 4 times x is 4x. I'm also going to do the 4 times the minus 3. Positive times a negative is a negative, and so I have 4x minus 12. So in front of that second term, you always need to have that plus or minus sign to separate your two terms. 4x minus 12 is just going to be my answer. Number 4, we're going to do the properties of real numbers. Before we had the properties of addition, which were our first 4, and now we're adding to that list. So commutative property of addition said we changed the order. We said our example for that was if I did x plus y and switched it around and put y plus x. But anytime the order is changed, that's your commutative property. Then we had our associative property of addition that said the parentheses have to be moved. The order is the same. So we had something like x plus y plus z equals x plus y plus z. And one of them had parentheses around the first two. On the other one, it was around the second two. So on this one, the parentheses are around the x and the y. Here, they're around the y and the z. Everything's in the same order. The parentheses are moved. Then we had the additive identity property. We said, what number can we add to a value and not change what we get? What can we add to 3 and still get 3? Well, it's adding 0 to something. So they're going to say that if I take x plus 0, it equals x. If I add 0 to something, I get the same answer. Additive inverse. Inverse means opposite. So the opposite of adding is subtracting. We said that when we took an x, and then my board doesn't want to work. So I'm going to rewrite the commutative. X plus y equals y plus x. The associative, x plus y plus z equals x plus y plus z. Parentheses around the first two, parentheses around the second two. Then we did the additive identity. X plus 0 equals x. Now we'll do the additive inverse. Additive inverse says we're adding opposites. So if we take an x plus a negative x, then it equals 0. Anytime you add opposites, you get 0. Those were the properties we had the other day. Today, we added the distributive property. We said the distributive property was used to remove the parentheses. So if I have something like, I'm going to move it over here, x times y plus z, we end up taking the x times the y, so xy, plus the x times the z, xz. And we've gotten rid of the parentheses by using our distributive property. Now notice when you get to the next ones, commutative property of multiplication, associative property of multiplication, multiplicative identity, multiplicative inverse, and then the multiplication property of 0. We had the commutative property of addition. It said we changed the order. The commutative property of multiplication is the same kind of thing. I'm just switching the order of my multiplying. So x times y is going to equal y times x. You may or may not have the dots there for multiplying, but just to show you, I'm multiplying instead of adding. Associative property, same thing, I changed the parentheses. So my associative property said if I had x times y times z and x times y times z, one would have parentheses around the first two, and the other would have the parentheses around the last two. So you'll have to watch out when you pick, it's going to be in the drop down that you pick the right one. Don't just look and say, oh, it's the commutative property. You have to know, is it of addition or of multiplication? Multiplicative identity. We said with the identity property, what you start with is what you want to end with. What number do I multiply times 3 to still get 3? Well, with multiplication, we're going to multiply something times 1. So they're going to say x times 1 equals x. If I multiply by 1, it's not going to change its value. Multiplicative inverse, that's kind of the weird one. At least I think it looks weird. The inverse of multiplying is dividing, but when we divide with fractions, we end up multiplying by the reciprocal. So the multiplicative inverse says if I take a value times its reciprocal, it's always going to equal 1. So their example is going to look like this. X times the reciprocal of x, which is 1 over x, equals 1. A number times its reciprocal is always equal to 1. And then the last property, multiplication property of 0, just like it sounds. If I take something times 0, I'm always going to get 0. So x times 0 is equal to 0. So if you go on the resource pages and print out RV30, properties of real numbers, it's going to have the words in there along with the examples. So if you're having a hard time, make sure you print those out. Otherwise, what I do is I look to say, am I adding? If I'm adding, it's 1 through 4. Am I multiplying? If it's multiplying, 6 through 10. Or do I have both adding and multiplying? Because then it's probably the distributive property. Here I'm doing adding and subtracting. I'm adding opposites. N plus a negative n equals 0. Looks like this one. X plus negative x equals 0. That's my additive inverse. I'm just going to write a 4 in there. The next one, I'm multiplying, so I know it's 6 through 10. 4 times 5 times 6. 4 times 5 times 6. Here the parentheses are around the 4 and the 5. Here it's around the 5 and the 6. I've moved my parentheses. That's this property here, the associative property of multiplication. Number 7. Here, oh, I look at this one and say, I got both multiplying and adding. Oh, the only property that had both was the distributive property. Does that look like the distributive property? Did I take the 2 times the a and then the 2 times the 9? 2 times a plus 2 times 9. Sure enough, there's my distributive property. The next one I'm multiplying, I hopefully recognize that I'm multiplying by 1. X times 1 equals x. There's my multiplicative identity property. Number 8. If you don't have all those written down yet, pause the video. I'm going to move down to the next problem. Number 5 then. Commutative property of addition, associative property of addition, additive identity, additive inverse. Those are my adding properties. The distributive property has both adding and multiplying, and then 6 through 10, my multiplying properties. So I look at this first one, I'm adding. A plus 4 equals 4 plus a. I've switched the order, commutative property of addition, which is our first property. Here, I have both adding and multiplying. Tells me it's probably the distributive property. I took 6 times the 7, d times the 7. I got rid of my parentheses. That's my distributive property number 5. Here, I'm adding opposites. I have a -3 and a +3. When I add opposites, I get an answer of 0. That's my additive inverse property. Inverse means opposite. Here, I have 1/5 times 5 equals 1. That's the one I said looked kind of weird. I'm taking something times its reciprocal, it's equal to 1. That's my multiplicative inverse property. Multiplying by the reciprocal. Multiplicative inverse, number 9. Go ahead, try to do the next 4 here while I'm moving the board. So on the next one, m times 1 over m equals 1. Again, that's the multiplicative inverse property. A value times its reciprocal equals 1. Multiplicative inverse was number 9. 2 plus c equals c plus 2. I just switched the order around. That's my commutative property of addition. So number 1. The next one, 5 times 9 times a, 5 times 9 times a. Here my parentheses are around the first 2, here they're around the last 2. That's my associative property of multiplication, so number 7. And the last one, 0 times b equals 0. Anything times 0 equals 0 is my multiplicative property of 0, so number 10. Number 7 says evaluating a quadratic expression with integers. Quadratic expression just means you have the highest degree of 2 has a squared term. So whenever it says quadratic expression, expect to see an x squared, an m squared, something squared in your problem. So it wants us to evaluate. We said before when we evaluate an expression, we put that value in parentheses. So m squared means I'm going to take -3 and square it. Plus 5 times the m value, because 5m means 5 times m, plus 9. If I follow my order of operations, I do the exponent first. -3 times -3 is +9. Then I do my multiplying. Right here in the middle we had multiplying. +5 times a -3 is a -15. Notice I just wrote the sign of the answer. I didn't put plus a -15, which it technically is, but this looks like a mess. Then I have the plus 9. Now I can do my adding and subtracting. With adding, we have the commutative property, so I like to add the ones with the like signs. 9 plus 9 is 18. 18 minus 15 then, going to give me an answer of 3. So on number 8, if I'm going to evaluate the expression y squared minus 8y minus 9 when y is equal to 5, putting 5 in for my y value. So 5 squared minus 8 times the y value of 5 minus 9. 5 squared, 5 times 5. 5 times 5 is 25. Multiplying, -8 times 5, negative times a positive is a negative, and 8 times 5 is 40, minus 9. So again, if I put these two together just because they're both negative, I'm going to have 25 minus 49. Now my rule is to subtract and take the sign of the larger one. The larger one is negative, and so I'm going to get -24 for my answer. Now if you're using your calculator, you could just punch it in, 25 minus 40 minus 9. It's going to give you the same thing, hopefully. Number 9, if I'm evaluating that expression, again I'm putting in -6 for my n, and I'm doing n squared minus 5n minus 7. So I'm going to take -6 squared minus 5 times -6 minus 7. Following my order of operations. Exponents first. So -6 times -6. Negative times a negative is a positive 36. Then multiplying. -5 times -6, a negative times a negative is a positive 30. And then I have my minus 7. So 36 plus 30 would be 66. 66 minus 7 is 59. If I grab my calculator quickly here, well, maybe not so quickly. If you are going to use your calculator on this first step, make sure that you don't type in negative 6 squared, because negative 6 squared is negative 36. You've got to type it in with the parentheses around it in order to get the right sign on your answer. So if I'm going to check this one with my calculator, I'm going to put parentheses, negative 6, close my parentheses, hit my x squared, so I have negative 6 squared, just like that, minus 5, and then in parentheses, my negative 6, close my parentheses, then the minus 7 on the end, minus 7. And again, if you don't know if it's a minus or a negative, use the subtraction key on the Casio. It will take it either way. And once I hit equals, I should get the 59. Number 10, we're going to use the distributive property. We're just getting a little longer. Wants you to recognize that you're just multiplying the coefficients. Those are the numbers. You're not doing anything with the variable part except bringing it down. A negative 5 times a negative 3x cubed, you're taking negative 5 times negative 3, which is 15, and then the x cubed goes behind it. Then I'm going to take my negative 5 times my negative 5. Negative times a negative is a positive 25. Again, try to avoid writing two signs. Just put the sign of the answer. Negative times a negative is a positive. Negative 5 times a positive 5u squared. Negative times a positive is a negative, and then 5 times 5 gives me 25, and the u squared is going to go behind that. These are not going to be like things. I can't combine x's with u's, and so this big long thing right here is all going to go in for your answer. You've gotten rid of the parentheses. So number 11, if I use my distributive property, negative 4 times a negative 2y. Negative times a negative is a positive 8y. And if it's a leading term, we don't need the plus sign. Everything else, we need the sign in front of it. Negative 4 times a positive 2v. Negative times a positive is a negative. 8 times 4 is 2, or 8 times 4. 4 times 2 is 8. How about I say that right? So negative 4 times positive 2 is negative 8, and then the v goes behind there. And then the last one, negative 4 times a negative 6. Negative times a negative is a positive. 4 times 6 is 24. So 8y minus 8v plus 24 going to be your answer. Number 12, same kind of thing, using my distributive property. It's just that they put this behind here, and they use the parentheses just to separate the negative sign, so you knew they weren't subtracting that 2. They're multiplying by that negative 2. And so 5 times negative 2, negative 10. And then I have a negative 5x times a negative 2. A negative times a negative is a positive 10x then. Then I have a positive 2v times a negative 2. Positive times a negative is a negative 4v. So negative 10 plus 10x minus 4v going to be my answer. The next ones, 13, 14, 15, we're combining like terms. When you combine like terms, you're just adding and subtracting the front numbers, the coefficients. And so in this case, if I'm taking 3u's and I minus 6u's, I'm taking 3 minus 6, and we're thinking of the u like the label. If I have 3 oranges minus 6 oranges, I'd be 3 oranges in the hole, because 3 minus 6 is negative 3, and my label is u. So number 14, when I combine my like terms there, I'm going to put these two together because they both have c's, and I'm going to put these two together because they're both plain numbers. Now when I have a negative 7c and a positive 7c, a negative 7 and a positive 7, negative 7 plus 7 is 0. 0 c's, we just cancel that out of there. You don't put c down because c means 1c. So if it comes out to 0, they just canceled out and they're gone. 7 minus 7 is none. 11 minus 2 would be 9. So in this case, the only thing I'm going to put down is 9 because my c's are gone. And on number 15, again I'm combining my like terms. These are both u squareds. You're not squaring the number, that's just the label on the variable. And so I'm doing the negative 2 plus the 9. Negative 2 plus 9 is 7 u squareds then. Number 16, we are going to simplify using the distributive property and combining like terms. So in this case, getting rid of my parentheses first. I'm just going this far because the parentheses are only around the x minus 6. So I'm taking 4 times x, which is 4x, 4 times a minus 6, which is minus 24. This minus 7x is just going to come down behind that expression. It's not in the parentheses, so it's not multiplied by that 4. Then I'm going to do the step we had before where we combined our like terms. I'm going to put these two together because they're like terms. 4x minus 7x. 4 minus 7 would be negative 3x. And then the minus 24 is just going to go down. And so negative 3x minus 24 is what I get when I combine my like terms. Number 17. Same kind of thing, only I've got 2 sets of parentheses. So when I do this, I'm going to multiply up to here, and then I'm going to do that side. So I'm going to start here. 5 times 3x is 15x. 5 times a minus 2 is minus 10. Then I'm going to go over here and do this side. A positive 4 times 2x is a positive 8x. Positive 4 times a positive 4 is a positive 16. Notice here I put my plus sign because it wasn't the very front term, and I'm going to end up combining my like terms. So I'm going to put my x's together and my numbers together. 15x plus 8x, 15 plus 8 would give you 23x. And then negative 10 plus 16. I've got to subtract. I get positive 6. So 23x plus 6 is what I get when I combine my like terms there. Number 18, same kind of thing. I got to use my distributive property first. I'm going to multiply just up to the end of the parentheses. So negative 2 times w is negative 2w. Negative 2 times a positive 3. Negative times a positive is a negative. 2 times 3 is 6. That minus 3w is just going to come down. So when I combine my like terms, negative 2 minus 3 would give me negative 5w, and then the minus 6. So negative 5w minus 6 would be my answer. After you do the shorter ones, then they get part B, the longer ones. So number 19, same kind of thing we just got done doing. I'm going to start and get rid of my parentheses here in the middle. This minus 4w in front is just going to come down. Now I'm going to multiply, but I'm not going to put my answer or my sign of my answer until I actually do my multiplying. When I do a negative 6 times a negative 2, a negative times a negative is a positive 12x. Negative 6 times a positive 6w. Negative times a positive is a negative 36w. And then again, this plus 4x is just going to go on the end because it wasn't in the parentheses, so it's not multiplied by anything. Then I'm going to go ahead and combine my like terms. I'm going to put my w's together, my x's together. So negative 4 minus 36, they're both negative. I add and keep the sign, so negative 40w. Here we have 12 plus 4, they're both positive. I add, So positive 16x. So negative 40w plus 16x is my answer. Number 20, same kind of thing, but this time I have two sets of parentheses. Again, I've got to multiply. Here I'm multiplying just up to the end of that parenthesis. So negative 6 times negative 4 gives me positive 24w. Negative 6 times a negative 2x. Negative times a negative is a positive 12x. Then I'm going to do my second multiplication. I'm not going to put my sign down till I do the sign of my answer. Positive 2 times a negative 7x. Positive times a negative is a negative, 14x. Positive 2 times a negative w. If you have a hard time remembering, that's a negative 1. Positive 2 times negative 1 is negative 2w. Combining my like terms then. We have 24w minus 2w, which would be 22w. We've got a 12x minus a 14x. 12 minus 14 is negative 2x. So 22w minus 2x would be your answer. Number 21, same kind of thing, getting rid of my parentheses. This is in front, so I'm just going to bring down the 4y. Then I'm going to multiply, writing the sign of my answers only. Negative 4 times positive 7z, negative 28z. A negative 4 times a negative y. Again, if you need to, put a 1 there. Negative 4 times negative 1 is a positive 4y. Negative times a negative is a positive. That minus z comes down. Again, if you have a hard time remembering, minus z is minus 1z. So when you combine your like terms, 4y plus 4y is 8y. Negative 28 minus 1, I have to add and keep my sign, so negative 29z. So 8y minus 29z would be my answer. And the last ones here say combining like terms in a quadratic expression. Again, your quadratic expression means your highest degree is a squared term. We have an 8x squared and a minus 11x squared. When we combine our like terms, we can't combine an x squared with a plain x. They're not exactly the same label. So in this case, I'm going to combine these two. They're the only two that have the exact same thing right behind them. So 8 minus 11 is minus 3x squared. The other two terms I can't put together, they're just going to come down. I have a plus 9x and a minus 6, and so my answer is negative 3x squared plus 9x minus 6. 23, when I look at that one, I've got a little bit more I can combine, because I've got these two that have x squareds and these two that have plain x's. So negative 18x squared plus 17x squared. Negative 18 plus 17 is negative 1x squared. However, in algebra, you don't need the 1 in front of there. A negative 1x squared is the same thing as negative x squared. If you type it in like this, it's going to tell you it's correct and then remind you that you don't need the 1. Doing my x's, my plain x's, I have a positive 10 and a minus 12. 10 minus 12 is negative 2x. And then that minus 6 didn't have anybody to combine with, so he just goes on the end. And so my answer is negative x squared minus 2x minus 6. By the way, if you did these in a different order and you put the minus 6 before the minus 2x, it's still correct. However, best form is what they call descending order, the highest exponent down to the number without a variable called the constant term. And number 24, looking at this one, combining my like terms, I just have this one, negative 7x squared. There's nothing to put with it, so it's going to stay negative 7x squared. Then I've got these two with x's. I've got a 6x minus a 6x. Well, 6 minus 6 is 0, so those are going to cancel each other out, and I'm not going to have any x's. Then I've got my numbers. I've got a -5 and a -13. My signs are the same. I add and keep the signs, so I get -18. So 7x squared minus 18 is going to be my answer. So keep in mind when you have opposites, 6x minus 6x and you get 0, you just don't write it down. There's nothing there. And then way over in another slice of your pie chart is going to be these ones. They're still in the same chapter, but they moved them, or they're in a different slice of your pie chart, so you're going to have to go hunt for them. You'll see where the little dotted white dots are. I want to simplify a radical expression that has a fraction under it. Anytime they use the word rational, tells me I'm going to have a fraction in my problem. So, I can't take the square root of 27 or the square root of 75. First thing I need to do is simplify my fraction. In this case, both of those are divisible by 3. The square root is still there. 27 divided by 3 is 9. 75 divided by 3 is 25. Now, if you notice, those are both numbers you can do the square root of. That's what should happen. The square root of 9 is 3. The square root of 25 is 5. The square roots are now gone because we took the square root of a perfect square. If I could simplify this fraction, I would. I can't, so 3/5 is just going to be my answer. Now, in number 26, we have the square root of 16 over the square root of 25. Those values are already perfect squares, so I just go ahead and do my square roots. The square root of 16 is 4. The square root of 25 is 5. I've gotten rid of the radical, the square root sign. I can't reduce my fraction, so 4/5 is my answer. And then number 27, again, I look at that and say, oh, again, I don't have perfect squares, which tells me I should be able to reduce my fraction. These, again, are divisible by 3. Still under the square root, 48 divided by 3 is 16. 27 divided by 3 is 9. Now I can do my square roots. The square root of 16 is 4. The square root of 9 is 3. I'm not going to write the mixed number. I just leave the fraction in simplest form, in lowest terms, so 4/3 is my answer. So that if I am going to use my calculator to check it, I'm going to use my square root button. I'm going to use the fraction, 48 fraction 27. On my calculator, I get 1 and 1/3. To change my mixed number to my improper fraction, shift and the fraction button. Shift and the ABC one. Then on my calculator, I should see 4 over 3, 4/3. So again, if you want to do them on the paper, check them with your calculator. Go ahead. I prefer you can do them on your paper without your calculator, but if you want to check them, that's perfectly fine. And that should be the end of homework day 11.